Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on trigonometric equations. So the last video on this topic, we solved trigonometric equations and used our calculator to come up with one solution. So now we're going to look at coming up with multiple solutions for a trigonometric equation. So once again, this is a trigonometric equation because it has a trigonometric function. And the way we solve it is we undo everything that's been done to the variable, in this case x. We do that in the opposite order to BODMAS. The last thing we undo is the sine, cos, or tan by taking sine inverse, cos inverse, or tan inverse. So a common question you'll get is something like this. You'll be asked to solve for x, and you'll be given a domain. So you'll be asked to say find all solutions for x between and including 0 and 360 degrees, obviously if it's in degrees, and you might be asked to find between 0 and 2 pi if we're in radians. So let's go ahead and solve this. So the way we come up with the first solution is exactly the same way we did so in the previous video. So we need to undo everything in the opposite order to BODMAS. So the first thing I'm going to do is undo the timesing by 2 here by dividing each side by 2. So if I divide each side by 2, I'm just left with what's in the brackets on the left-hand side. And on the right-hand side, we'd just be left with 5 over 2 or 2.5. Note, you could have solved this equation by expanding the brackets. Nothing wrong with that. I'm just doing it a different way. So the next thing we do is we get rid of the 4 by subtracting 4 from both sides. Of course, we subtract because this is a positive 4. So the left-hand side just becomes negative 3. The negative doesn't go anywhere. Negative 3 cos 2x equals 5 over 2 minus 4, which is negative 1.5. Now we're going to divide each side by not 3, but by minus 3. And that will leave us with the cos by itself. So then we will have cos of 2x equals minus 1.5 divided by minus 3 gives us a half. So now we're going to take the cos inverse after we've done all these other operations. So what we will be left with if we take the cos inverse of this side is 2x. What we get on the right-hand side is the cos inverse of a half. Now this is where other solutions come in. So the cos inverse of a half has infinitely many solutions. So hopefully you know from our exact values that cos inverse of a half is 60 because cos of 60 equals a half. So we have 2x equals 60 is one solution. But you also remember from the unit circle that cos of 360 minus 60, cos of 300 is also equal to a half. And because you're so smart, you also remember that if we're taking sine inverse, cos inverse, or tan inverse, if we get a solution, we can just add or subtract to it multiples of 360 without changing the answer. So there would be other solutions to this. You know, we could add 360 to 60 and get 420. Similarly, we could take 300 and add 360 and we'd get 660. Of course, we could also subtract 360. So if I subtracted 360 from this, I'd get an answer of minus 300. And if I subtract 360 from this one here, I would get minus 60. So these are some of the solutions. There are infinitely many solutions to cos inverse of a half. So all of these are not actually answers to x. They're not what x equals, they're what 2x equals. So we just can divide each of them by 2. So x, possible solutions are 30, 150, 210, 330, minus 150, and minus 30. Okay? So we were told originally we only want to include solutions between 0 and 360 degrees. So these 4 here, they will all be valid solutions. We don't include these last 2 because they're outside the domain. So it's very important we think about the trigonometric graphs and the number of solutions. So if we look at the normal cos graph, y equals cos of x. So we know that that graph starts off at 1, at y equals 1, sorry. It goes down, and then it comes back up to 1 when x is 360 degrees. So if I were to put in, like, a half would be here. There are normally two solutions between 0 and 360, and we found them, 60 and 300, right? But if I am to graph y equals cos of 2x, remember that changes the period. So that graph, y equals cos of 2x, it still starts here, but what it does is it goes down and up, and it actually finishes at the same spot, but there are 2 cycles between 0 and 360. So for that one, there would actually be 1, 2, 3, 4 solutions. There are 4 values of x you can sub into this equation, 4 values between 0 and 360 degrees that make it equal a half. And these are, of course, the 4 solutions we just found. If I substitute any of these 4 solutions into this equation, I will get a half. So that's why there were 4 solutions. So we found all the solutions in degrees. Of course, if we want to find them in radians, all we need to do is change each of our 4 solutions to radians by timesing by pi over 180. So 30 is equal to pi on 6. 150 is equal to 5 pi on 6, and then we have 210 is 7 pi on 6, and 330 is 11 pi on 6. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.